There we go. All right, a conical tank with the vertex down is 6 feet across at the top. Okay, so we have a tank like this, and it's 6 feet across at the top, so that's 6 feet and 10 feet deep. So the total depth is 10. Now that means that no matter where I draw the picture, like here, it's going to be that same ratio of
Oh,
the height.
wait. I did the whole problem with 6 as the diameter and 3 as the radius.
Oh, yeah, that is what it is. My bad.
Okay.
It's 6 feet.
I was like,
Yeah,
that would
no,
have been a really dumb mistake.
you're right. Thank you. So there's 3. So 6 feet across the top and 10 feet deep. So that means that the ratio of radius to height is always going to be 3 to 10.
Yes.
Right. All right. So if the water is flowing into the tank at a rate of that many cubic feet per second, so this is your what variable would I call this?
dv dt.
That's right. That's the change in volume over time, dVt dt. So that is flowing into it. So it's a positive. So it's 10 cubic feet per minute. It says find the change, the rate of change in the depth of the water. So they want us to find d what?
dh dt.
That's right. They want to find dH dt at the point that is 6 feet deep. So thank you for writing the formula up there. So what we're going to do is we'll take this equation and we're going to take the derivative with respect to, well, actually, the first thing we're going to do is we're going to rewrite this in terms of H.
Mm-hmm.
No, let's see that what we're going to do.
I had 1/3 pi, and then in parentheses 3h over 5 squared times h.
H over 5 squared. Why'd you do H over 5?
3h over 5. I mean 3h over 10.
There you go. Okay, yeah. So this is our formula here. Good. So our formula right here, that's why I wrote that earlier. We're going to have to convert this because we want to find dH dt. So we'll have to solve this for H. So we'll flip both sides. H over R equals 10 over 3. Got it? So then we're going to multiply both sides by R. So H equals 10/3 times R. Right? So we're going to rewrite the volume in terms of H. So it's going to be, I'll just write the pi on top. Pi over 3 times times R. Let's see. No, hold on. My fault. I want to rewrite the R in terms of H. My bad. Try that again. I want to write R in terms of H because I want V in terms of H.
Oh yeah.
That makes sense. So what I want to do instead is write R equals 3 over 10 times H. So
Yeah.
R would be 3H over 10 squared times H. So we have the volume is equal to pi over 3 times 9H squared over 100. Actually make it 9H cubed, right?
Yeah.
And then we can even cancel out this 9 with that 3. And so writing it more simply, it's just 3 pi over 100 times H cubed. That is the volume in terms of H. Did I do that right? It looks like I did it right. Yeah?
Yeah.
Follow how I did that? Is that what you did?
Yeah.
And then we're going to take the derivative with respect to time for that. So we have dv dt equals, now we're going to do the derivative of H, but we're going to use the chain rule, right? So it's 3 times that to the second power. So 3 pi over 100 H. I leave the H in there. And then I multiply that by the derivative of H because that's the chain rule. Yep. Do you get why I'm doing that?
Yes.
Okay, so you're good with all that? All right,
Yeah.
now we just go and plug in all those values. So we're trying to find DHDT, so I'm going to circle that. That's what we're trying to solve for. We know what H is. They said when it's 6 feet deep, so we're going to plug in 6 for H, and we know dVdt is 10 feet cubed per minute. So this is 10. That was 6. So we have 9. Whoops, start over again. Plug in a 6 in here. When I plug in 6 there, that's going to be 18. Let's see. It's going to be 18 pi over 100, which I could simplify a little bit, I guess, squared times h squared times dh dt. Whoops, no. And what am I doing? H is already in there. So it's just that times dh dt, right? I plugged in for h. dh dt. So that's just something I can plug in my calculator to solve for dh dt. I just divide both sides. So 10 divided by that mess right there. So 10 divided by 3 times, let's see, that's really 9 over 50. 9 pi over 50 squared. And punch that in your calculator carefully. 10 divided by 3 times 9 pi. Where's my pi? Nine pi over 50 squared. And then close the parentheses off to make sure you're doing it right. Check it again, make sure you plugged it in right. Looks like I did. And there's my answer, 10.42. Don't know what they want you to round it to. I'll call it 10.42. 10.42 feet per minute because it's one dimensional. Make sense?
Turkey has 0.982 feet.
Your formula that has that 0.982? The answer key. What did you get when you did this?
I got 0.278.
Okay, so what I do wrong? Did you see a mistake that I made somewhere?
No.
3h over 10. I'm going through everything here. The volume. Is this formula correct?
Yeah.
1 pi over 3 r squared h. That does look correct to me. We're sure it's pi over 3? We're sure it's 1/3, not 4/3? I feel like, what was which one? Oh no, 4/3 was a sphere, volume of a sphere, never mind. Let's see, pi over 3. I plugged in that correctly. 3h over 10 squared. Squared is 9 over 100. That's right. 9 will cancel with 3. You get 3 h cubed over 100. So that's 3 pi over 100 h cubed. dVdt. Taking the derivative is 3 squared times dh dt, and then I leave. Oh, here's what I did wrong. This doesn't get squared. That shouldn't be squared. Okay.
Wait, what?
My fault. This should not be inside there. So when I'm doing this, when I take the derivative of this right here,
Mm-hmm.
Here, let me just, I was kind of doing a little bit of shorthand. Let me start this over. Here's the volume, and it equals 3 pi over 100 h cubed, right? So when I take the derivative of this whole thing with respect to t, I get dv dt on the left And then I should take this 3 pi over 100 out. And then I should multiply it by the derivative of h cubed, which is 3h squared, and then multiply that by dh dt. You see what I'm saying? I had squared the 3 pi over 100. I should not have done that.
Oh, okay. Oh yeah, because it's a constant. Okay.
Yeah, because it's a coefficient. Yep.
Okay.
It's the coefficient. So now when I do this, it's going to be now when I plug in 6 for h, I'm going to get and 10 for dv dt. So 3 pi over 100 times 3 times 36 dh dt. So let's see if this works out better. Let's see if I can steal that. It's going to be, whoops. It's going to be 10 divided by, let's see, 3 times 3 times pi times 36. Okay, that's going to be on the top, and then I'm going to divide that by 100. Let's delete that. No, that didn't work. They don't like those, how I've written it in there. All right, let's just try it over again. Let's see. dH dt equals, it's going to be 10 times, I'm going to just flip it. Basically, I'm going to multiply it by 100 and divide it by 3 times 36 times pi. So it's 1,000 divided by, do you understand what I did there?
Yes.
1,000 divided by 3 times 36 times pi. There we go. Is that the answer?
Yes.
All right, my fault. Yeah, I was careless with that other thing I did. So you see how that worked?
Yeah.
It's funny. I did this one just the other day with somebody. I don't know why. I don't know why I made the mistake. All right, you want to skip to the next one,
Yeah.
or you want this one?
We can skip to the next one.
Page 2. Okay, page 3.
Yes.
The limit as x goes to 3 from the right. Well, do you remember what this looks like? Do you remember how this is just a rational function? And do you remember this would give you a vertical asymptote at 3? 1, 2, 3. Do you remember this?
No, I was trying to do it algebraically.
Yeah, I mean, you can do it algebraically, but it's good just to visual. I think in this case, it's good to just visualize it.
Yeah,
Because
I'll make it easy.
you can do it algebraically by just plugging in values. You could do it that way. You could take your x and your y and you could plug in from the right. So it would be 3.1, 3.01, 3.001, and you can just plug those in. But and that's fine, right? If you did that, plugging in 3.1, you get 6.1 over 0.1, right? So that's pretty small, but is it positive or negative? Anytime you divide by, I'm sorry, not pretty small, pretty big. Anytime you divide by a small number, what does this whole number mean? That whole number is that this number is a bigger number, right? Because you're dividing by a really small number, that makes this fraction a very large number. See what I'm saying? And then when you plug in this 3.01, you would get 6.01 divided by 0.01. That's an even bigger number. Then when you plug in the other one, you would get 6.001 divided by 001, which is an even bigger number. Because the number on the top isn't really changing much at all, but each time you're dividing it by an even smaller number, which is going to make this entire thing a much bigger number. You follow what I'm saying? That's one way you could do it. So you know it's just going to be positive infinity. Or you could graph it. If you can go back to graphing, you'd be like, oh, I remember this. This function or this graph just looks like, here's -3 is my x-intercept. My x-intercept is where the numerator equals 0, right? So it's at -3. My y-intercept is at -1. And so my graph, and my horizontal asymptote is at 1. Remember why? Because the leading coefficients when the degree is the same. It's the ratio of leading coefficients. Okay. So you could just real quick in your head, just sketch the graph real quick and you'll be like, oh, right, I remember now. So when I'm coming from the right, I'm approaching positive infinity. If I was coming from the left, I would be approaching negative infinity.
Okay.
Does that make sense?
Yeah.
All right. Trig limits. Do you remember how to do this one? You factor out, basically you factor out whatever you need to so that this is the same as what was up here. So rewrite this as the limit as x goes to 0 of 1/3 times sine of 2x all over 2x.
Oh.
Do you see how I did that?
Yeah.
Which equals, now that 1/3 can come all the way out in front. The limit as x goes to 0 of the sine of, we'll just call it u over u. And what's the sine of u over u? Well, I shouldn't say u. I should say 2x over 2x. But what is the rule when you have the sine of as x goes to 0 of something of x over x?
0, right?
I don't remember, is it 0 or is it 1? One of them is 0 and one of them is 1.
Oh, I think it might be 1 because the answer is 1/3. So then that would make sense.
Yeah, I think this one is 1. I think the cosine one is 0.
Okay.
Yeah, so that just equals 1/3 times 1, which equals 1/3.
Yeah, that makes sense.
Got it? So for this one, the limit, what you would do is you would factor this, and notice how this is a difference of cubes. Do you remember how the SOAP property? You remember the SOAP factor trick? If I have a minus b, a cubed minus b cubed. Do you remember?
No.
Maybe you didn't learn it. It's the same sign, the opposite sign, and always the positive sign. So the same sign would be a negative, the opposite would be a positive because the sign was a negative. So it's the same sign, opposite sign, always a positive sign. And then you just take these, whatever's being cubed, you put it here and here, you square it here and here, and you multiply them together here.
Oh.
So this, what's being cubed here is, this is your A and 2 is your B. Got it? So to factor this equals the limit as x goes to -1 of, I'm going to factor this out. The same sign would be a negative. The opposite would be a positive, always positive at the end. Take your x plus 3, put it there. Take your 2, put it there. Take your x plus 3 squared and put it there. Take your 2 squared and put it there, and multiply them together here. And then you've got x plus 1 on the bottom. You get how I did that?
Yeah.
Okay. And now look at what happens. What does this thing turn into? I'll simplify it in blue. This just turns into x plus 1, which can be canceled with that down there.
Oh. Okay.
And so your limit as x goes to -1 of just whatever you had, you don't even have to really simplify this stuff. You can just plug it in. You can simplify it if you want, but just plug it in, right? It's just easier to plug a -1 in. Now I can just plug in -1 for all those x's, and I won't get an indeterminate solution there. So this is 2 squared, which is 4. This is 2 times 2, which is 4, and that's plus 4 at the end. So your answer is just 12.
Oh, okay, that makes sense.
That make sense?
Yeah.
Good guess on the number of questions there. See if I can quickly answer this one. Yeah, in the morning, I'll do this real quick. When the sun is passing directly over the shadow of 80-foot building, yada, 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 the angle theta, yep, this is your angle, good, is increasing at a rate. So d theta dt equals 0.27 radians per minute. Okay, at what rate is the length of the shadow? So we'll call that dl dt, and this bottom distance is L right here. Okay, so the key here is that you want to use a trig function that relates theta with 80 and 60. You don't
Wait,
want
what?
100.
What's DD?
D theta,
Oh, okay.
this is DL.
Okay.
You don't need anything else, because what you're going to do is you're going to say that the cosine, I'm sorry, not the cosine, you're going to say that the tangent of theta is equal to the opposite, which is always 80, over the adjacent, which is L in this case. Do you understand? That's the formula you want to use. Don't use the sine and don't use cosine, because this 100 changes. The length, this hypotenuse changes as well as the sun changes. But what does not change? What length, what distance does not change ever on this picture? The building height. The building is always 80 feet high. So that's what you want to use. Okay. So we're going to take the derivative of this. Well, let's rewrite this. L times the tangent of theta equals 80. So now let's take the derivative with respect to time. So we're going to have to use the product rule. So dl dt times the tangent of theta plus L times, what's the derivative of tangent?
Secant squared.
I don't remember, is that right? Secant squared theta, yeah, equals 0, because the derivative of 80 is just 0. Got it? Now what's the tangent of theta at they say at that moment. So what's the tangent right now of this? Tangent is what? It's opposite over adjacent, right? So it's 8 over 6, or 4/3, right? So dl dt, which is what they want us to find, plus what's the length right now? It's the length at this moment that they want us to find these things. At what rate is the length of the shadow decreasing? They're talking about at this point when there's a 60-foot long shadow.
Oh, so it's 60.
It's 60. And I'm sorry, I missed something here. I forgot to put in d theta dt, right? Because I have to use the chain rule.
Do
you understand that?
Yeah.
So what's secant squared? The secant is the hypotenuse over the adjacent. So it's 5/3. So secant is 5/3 d theta dt. Oh, sorry, I know d theta dt. What's d theta dt?
0.27.
0.27. And so now I solve that for dl dt. Take that whole thing basically subtract this whole thing and then multiply it by 3/4. So
Okay.
let's do that. Let's see if that works out. 60 times 5/3 squared times 0.27, and let's multiply that by 3/4. Multiply that by 3 and divide it by 4, and then the negative, our answer is going to be negative. Is that the right answer?
Yes.
Negative 33.75. What units are we using? Feet per, are we in minutes? Per minute. Got it?
Yeah,
All right. Hopefully that helped.
it did. Thank you.
Good to see you. I'll see you next week.
Thank you.
Bye-bye.